Good afternoon, everyone. Welcome to the blockchain workshop under the Udhyamita program of Pitchtember Fest by NIT Patna Incubation Center. I'm Siddharth Shukla. I'm from Hackslash Club, Team Cypher Sync of blockchain, and I'll be your facilitator today. So, in this workshop, we will be covering the basics of blockchain technology, including its introduction, how it works, its potential applications, and future opportunities in blockchain. We will also discuss we will also discuss some things about development of blockchain as well as some basic applications of blockchain like cryptocurrency, etc. I hope you find this workshop informative and engaging. Let's start. So, the name of the workshop is Leisure Launch, and here let's start with Leisure Launch. So before we begin, I would like to introduce you all with what we need to do and discuss in this workshop. So first of all, we will be getting introduced with blockchain. Then I will tell you guys what's the difference between Web 2 and Web 3. We will discuss some more points about cryptocurrency. Then we will go deep inside cryptocurrency and discuss about Bitcoin and Ethereum, and then we will some discuss some basic terminologies about blockchain. Then we will let then we I will let you all know about smart contracts, and that's the coding part of blockchain development part. We will go in depth about development part of blockchain, and then we will discuss about solidity. Then we will see some use cases of blockchain in the real world, some applications of blockchain which we can implement in real world or which are already implemented in real world. Then we will have a glimpse of decentralized finance. What is decentralized finance and how blockchain is revolutionizing finance using DeFi. Then we will discuss some job opportunities with blockchain. So let's start with this. What even is a blockchain? So you guys must be thinking about what is a blockchain or what even is a blockchain. So basically, blockchain is a chain of blocks, as its name signifies. Now, what is a block? A block is simply a container that contains some transactions included in the public ledger. Now, you guys must be familiar with the term ledger. Ledger is basically, you guys must have seen shopkeepers, local shopkeepers maintaining a ledger. So, blockchain is basically a chain of blocks, and a block, it consists of a public ledger. A block consists of transactions which are included in a public ledger. So, if we talk about blockchain, so blockchain is simply a distributed ledger technology that allows secure, transparent, and tamper-proof transactions. It's a chain of blocks which is very secure and it's tamper-proof as well. Each block in the chain consists of a set of transactions that have been verified. Each block has certain set of transactions that have been verified and recorded in a ledger. Now, once a block is added to the chain, it can neither be altered nor be deleted, which means it is tamper proof or immutable. So basically, the blockchain was revolutionized or popularized by Satoshi Nakamoto. You guys must be familiar with this name or maybe not. He was the founder of Bitcoin, and which was released in 2009. So we don't know who he is, or he is a person or an association or something, but the name on the white paper was Satoshi Nakamoto, the Bitcoin white paper. Now, so the revolution was started through Bitcoin, but now it has been like widely being used and in many other fields as well, the blockchain technology. Now let us go in Web 2 versus Web 3. What is Web 2 and what is Web 3? Okay, so I would like to give you an example. So let us say that I have to make a transfer of money to my friend, to any of my friend through any other third person, let's say. So But what if I want to give my friend an amount of 1,000 rupees, but when I give the third person 1,000 rupees and he gives my friend just 800 rupees? Now, let's say there are a number of intermediaries involved, like there are third person, fourth person, fifth person. Now, let's say I give 1,000 rupees to third person, he gives 1,000 rupees to fourth person, and he gives 800 rupees to fifth person. Then fifth person gives to my friend, and my friend gets just 800 rupees. So, like, would my friend or I would get to know who has done the cheating, who has done the fraud, who has those 200 rupees? No. So that's why blockchain technology involves no intermediaries. It's a direct contact between me and my friend. There are no intermediaries involved. So blockchain technology basically automates all the tasks that we currently rely on intermediaries to perform. Now let us go in this Web 2 versus Web 3 one. Web 2 is the normal web which we use nowadays. It is centralized. Basically, Web 2 is like Google Chrome or Microsoft Edge. It is also known as social web or participatory web. I guess it was started in early 2000s or late 1990s, and its basic characteristics are interactive and user generated content. It is more dynamic and engaging. But the problem with Web 2 is that it is centralized. Like there are centralized servers where your data is being stored. So if Chrome decides to shut down its servers, then all your data has been shut down. Like if Google decides to shut down its servers, all the photos you have backed up in Google Photos, they would have been gone. Now let us introduce to Web 3. Web 3, it is also known as semantic web or decentralized web. It is the revolutionary technology which aims for decentralization. In Web 3, basically, users have more control over their data and privacy. It is the next generation of internet. So basically, Web 3 addresses the limitations which were there in Web 2, particularly in terms of data ownership, privacy, and control, as I said earlier in Web 2. So there are some key characteristics of Web 3 which distinguish it from Web 2. The first of all is the most important one, and it is decentralization. Web3 applications strive to operate on decentralized networks, eliminating the reliance on centralized platforms and intermediaries. And the second one, as I discussed earlier in Web2, its limitation was data ownership. Now, in Web3, data ownership, the user, ownership remains with the user. The user has control over their data, not the server or the centralized authority. So, in Web3, the user decides how and with whom their data is shared. Now, let us take one more example. You guys must have watched YouTube. So, in YouTube, you guys must have also subscribed to your favorite YouTuber. In YouTube, you guys must have noticed that YouTube puts down the videos of creators even if it does not violate any YouTube policies. Now, why does it happen? Because the power is in YouTube's hands. It can do anything with all our data as well as our hard work that we put in our videos. So this is the limitation of Web 2, which is covered by Web 3. Now let us see a small table, the difference between Web 1, Web 2, Web 3. So basically, if we go, Web 1 is basically like we crawl, Web 2 is walking, and Web 3 is running. Web 1 is mostly read only, like HTML, just HTML things, and Web 2 is widely read, right? Like we can read also and we can write also. And Web 3 is portable and personal. Web 2 has community focus, while Web 3 has individual focus, as I said. And Web 1 was company focused. And Web 1 is basically home pages, Web 2 is blogs or wikis, Web 3 is live streams or waves. Now, Web 3 has smart applications, Web 2 has web applications, and Web 1 has web forms. Web 3 basically has decentralized applications as well. You would get to know this term earlier in the session itself. Now, Web 3 has a major feature called semantic web. It means that Web3 aims to make online content more machine readable and understandable. This enhances search capabilities as well as enable intelligent interactions between the user and the machine. Now, yes, you can see examples as well. Web 1 example is Britannica, Web 2 it's Wikipedia, and the Web 3 is Semantic Web. Now, let us go in cryptocurrency. Now, you guys must be familiar with the term Bitcoin or Ethereum or Dogecoin or crypto as well. Crypto, you guys must have been listening to the term crypto lately. So, what is a cryptocurrency? Cryptocurrency, also abbreviated as crypto, it is a digital or virtual currency that is used in a major application of blockchain. It's basically a currency that uses cryptography for security, and it is decentralized as it is a product of blockchain technology. So basically it means it is decentralized, which means it is not subject to any government or financial institution control. No one can control, no government or no centralized authority can control cryptocurrency. Cryptocurrencies are often traded on decentralized exchanges. Like you guys must be familiar with tradings, and you guys must have seen that people trade cryptocurrencies like Bitcoin or Ethereum, or there are many other cryptocurrencies as stable coins, etc. So these are also traded. Also, these transactions, the trading transactions which happens on all these apps like Grow or other apps, Binance, etc. These are all recorded on a blockchain. All the cryptocurrencies transactions are recorded on a blockchain. Now, as I said earlier, blockchain is a distributed ledger on which transactions are recorded. So basically, cryptocurrencies transactions are recorded on a blockchain. It's recorded on a block. Some transactions are recorded in a single block, and some blocks together form a chain. That's a blockchain. Then, each computer on the network has a copy of the blockchain. Each participating computer in a blockchain network has a copy of the whole blockchain, and any new transaction must be verified by all the computers on the network, and then it is added on the blockchain. Until and unless a transaction is verified by all the participating computers or by majority of the participating computers, the transaction won't be added on the blockchain. Now, key features of cryptocurrencies: decentralization, as I discussed, security, transparency, immutability, and pseudonymity. Now, let us say, okay, continuous development, increasing adoption, potential integration with traditional finance, and shaping the future of digital payments. These are some characteristics of cryptocurrency. Now, let us discuss some uses of cryptocurrency. Cryptocurrencies can be used to purchase goods and investments. They can be also be invested, like they have been in use in the market lately. So you guys must have heard about this. And they can also be used for sending or receiving money or storing wealth and accessing decentralized financial applications as well. Now, what are the benefits of cryptocurrency over the paper currency we use, like these notes or credit cards or debit cards? Now, the one of the major features that cryptocurrency has advantages, it is cryptocurrency security. Cryptocurrency is very secure as it is based on blockchain technology. There is no centralized authority like bank or central bank or the reserve banks that are of every nation involved. So there is no toll of your money or anything else. So it is basically decentralized. Cryptocurrencies are very transparent as well. The transactions that we perform on any cryptocurrency blockchain, are transparent and can be viewed by anyone on the blockchain. Now, cryptocurrency transactions typically have low fees as compared to traditional financial transactions, as there are no intermediaries involved. And it is one of the very major feature of cryptocurrency that the transactions that that are happening on cryptocurrencies are borderless, which means that they can be sent or received anywhere in the world without any limits. Now, let us move forward to Bitcoin. So, you guys must have heard the term Bitcoin. It is the most famous cryptocurrency, and so basically, it was created in 2009 by an anonymous person or a group of people. We don't know who, but it was an anonymous entity known as Satoshi Nakamoto. So basically, Bitcoin is also a cryptocurrency or a digital currency which has no central bank or single administrator, and it is based on a peer-to-peer technology, which means that the interaction is peer-to-peer and there are no intermediaries involved. Now, in Bitcoin, transactions are verified by network nodes through cryptography and recorded in a blockchain. It is a public distributed ledger, as I have been repeating. So, Bitcoin is basically a unique cryptocurrency which has a finite number of them which will ever be produced. In only 21 million Bitcoins will ever be created. So, since it's a finite resource, the price of Bitcoin is varying very and very ununiformly. Now, let us discuss some key characteristics of Bitcoin. Like every other cryptocurrency, it is decentralized, secure, transparent, etc. But one major feature that distinguishes Bitcoin from other cryptocurrency is that the number of Bitcoins which ever be created will be a finite number, which will be making it a scarce resource in future. Now, there are some features of or benefits of bitcoins which are like fast transaction. Bitcoin transactions are typically processed very quickly, which is a few minutes duration, and the transaction fees in bitcoin is very low as compared to other cryptos, which makes it a very good currency to trade or to exchange. Then increased financial inclusion. Bitcoin can be used by anyone with an internet connection, regardless of their location or financial status. It is basically a general feature of cryptocurrency. Now, Bitcoin or crypto in general has the potential to revolutionize a number of industries, including finance, supply chain management, voting, etc. Yes, I would like to inform you guys about the Bitcoin white paper, which was published by this anonymous entity known as Satoshi Nakamoto. I would like you guys to refer the Bitcoin white paper. It will help you understand about Bitcoin in more depth. Now let's go into Ethereum. Ethereum was proposed by Vitalik Buterin, a young programmer and co-founder of the Bitcoin magazine. So a part of the Bitcoin magazine, he proposed Ethereum, which is a better or a latest cryptocurrency than Bitcoin. Yeah, than Bitcoin. So basically, Ethereum is a decentralized blockchain platform that enables the creation of decentralized apps as well. Now, Bitcoin was just for trading or just for financial things, but Ethereum, uh, with the introduction of Ethereum, blockchain also blockchain was not just limited to trading or finance, but also for development. It also came to be handy for development. Now, Ethereum, what makes Ethereum different from Bitcoin? Ethereum enables the creation of smart contracts as well as decentralized applications, which are Web3 based applications. Now, DApps are basically applications that run on Ethereum blockchain. Ethereum is the second most popular cryptocurrency right now after Bitcoin, obviously, and it is also used to uh, develop obviously decentralized applications, but is also used to trade as well, just like Bitcoin. Now it has some consensus it has right now proof of stake, but it was introduced with proof of work. We will be dealing with proof of stake or proof of work later. Now its native currency is called ether or eth, just like bitcoins called btc. Now As the slide shows, it allows development part of blockchain, and these DApps are executed on the Ethereum network on the Ethereum virtual machine, which is also known as EVM. Now, some key characteristics of Ethereum are that other than those which we have discussed earlier of Bitcoin or blockchain, as all this is based on blockchain, so all the blockchain characteristics are already included in all these technologies. So basically, this one is programmable. So what makes Ethereum different is Ethereum allows the creation of smart contracts, which are self-executing contracts that can be used to automate a wide range of tasks, which is one of the major features of blockchain technology, automation. Smart contracts help in automation. And Ethereum is a Turing complete language. Now, what is Turing complete language? It means that it can be used to express any computation or anything that can be expressed algorithmic. It can be expressed using Ethereum too. Now, some of the potential benefits of Ethereum are Ethereum's efficiency is more than Bitcoin. It has an increased efficiency at it as it can be used to automate a wide range of tasks, which can reduce cost as well as limit the energy and save the energy which is being fed up. Now, reduce risk. Smart contracts which are based on Ethereum can use to reduce the risk of fraud and errors, increase transparency as well as uh, accountability. Now, it is basically the major feature of Ethereum that it is more transferable and traceable, which can increase the accountability and reduce corruption. Now, there are many new opportunities as Ethereum is a new blockchain or new cryptocurrency. Basically, Ethereum is also a blockchain. So, it is basically a development environment as well, not just cryptocurrency. It has the potential to create new opportunities for businesses as well as individuals. Businesses in trading or etc. And individuals as well in development of Web3 based applications. Now, Bitcoin versus Ethereum. So Bitcoin was the first cryptocurrency that was founded by Satoshi Nakamoto, and it was founded in 2009. Ethereum is just has been founded in 2015, and it is far more recent, as I told you guys earlier. Now Bitcoin takes 10 minutes to 1 hour to settle transactions, while Ethereum is much faster, which typically takes 12 seconds for a transaction to get settled. The reward for mining Bitcoin halves about every 4 years, and it is currently valued at 12.5 Bitcoins. I would like to go in the mining part in the later part of our workshop. Just for now, just we can say that Bitcoin takes much more time than Ethereum to for transactions to happen. And the Ethereum, when was started, it worked on proof of work algorithm, but now it is working on proof of state algorithm. But the and I will go into this mining part later in the workshop. Now let us discuss some basic terminologies involved with blockchain. So first of all, decentralization. As you guys must have got the hang of it, that what decentralization is. Basically, decentralization means anything which is not centralized. Centralization means the distribution. The Centralization means control of something or authority of decision making uh, uh, is lies within a single organization or a single person. Now, decentralization means distribution of this authority or control across a network of participants, or rather, we can call it nodes in technical terms. So, basically, the participants participating in a blockchain are termed as nodes. So, rather than relying on a single central entity, all this authority is divided in different people, like we can see in this diagram. Centralized means this single authority has all the power, and it's controlling all other people. Now here different authorities has have powers which are being this means decentralization, as the authority and decision making ability is distributed among many people, so it is decentralized. Now, why decentralization is favorable? Decentralization is favorable because it fosters trust through transparency, promotes inclusivity and individual empowerment, and reduces cost by eliminating intermediaries. So, yes, it fosters trust. You guys must have been thinking that how can decentralization foster trust? Now, let us, as I gave you an example of those that amount one that I give thousand, I want to give 1,000 rupees to my friend. So, if there are no intermediaries involved, or let us say that the blockchain is transparent. If I get to know whom am I giving money, and who whom is he giving money. So if I get to know all this, then it's basically completely transparent. So if I already know that where is my money going, so I would get to know if some fraud happens. So it would foster some trust in me as well as my friend. So transparency is a very large contributor in trust between users. It also reduces cost by eliminating intermediaries. Now, on a blockchain technology, since it's decentralized as well as it has no intermediaries, now since it has no intermediaries, so the costs of operations are also cut. Now, what is consensus? Consensus is any mechanism used where where the participants of the blockchain, or where the participants or of any technology need to agree on the state of the system. Like consensus is any mechanism where participants can agree to validate transactions or state of the system or validity of transactions. So basically, consensus are of many types like proof of work, proof of stake, DPoS, proof of authority, DAG consensus, etc. But majority of blockchains rely on proof of work or proof of stake. So what is proof of work? Basically, proof of work and proof of stake are two different consensus mechanisms, as I told you. They are used to validate transactions and secure blockchain networks to a greater extent. So, proof of work. Let us discuss about proof of work first of all. In a proof of work system, miners compete to solve complex mathematical puzzles. So, what basically a miner is? A miner is someone who contributes in blockchain technology. Like basically, uh, in proof of work, miners compete to solve a mathematical puzzle, and whosoever completes or solves the puzzle first, he gets to he gets to add the next block of transaction to the blockchain. Now, what is a miner? Basically, blockchain miners are people who add these transactions to blockchains, like blockchain, the major chain of the or the global chain of the blockchain. So, if someone is adding a transaction, like these are people who are interested or to add transactions in a blockchain. They can be anyone, but mining involves it requires a very sound system, so not everyone can participate in mining. So the first miner to solve the puzzle gets to add the next block of transactions to the blockchain, and in return of adding the transaction to the blockchain, he or she gets an amount of cryptocurrency. So this process is called mining, but as I told you earlier, it requires a lot of computational power. So it's not possible or feasible for everyone to participate in mining. Now, as we have already discussed proof of work, now for proof of stake. Basically, in proof of stake, the miners are called validators. Those people who were being called miners in proof of work are called validators in proof of stake. Validators are chosen to validate transactions based on the amount of cryptocurrencies they have staked. Now, in proof of stake, we have to stake a certain amount of cryptocurrency in order to take part in the blockchain. So, the more cryptocurrency a validator has staked, the more likely they are to be chosen to validate a transaction. So, validators are in return of validating transactions. validators are rewarded for validating transactions with cryptocurrency. So they are also rewarded with cryptocurrency. Now let us discuss some more basic terminologies. Now key and addresses. I would like to show you this. Yes. Now you guys may see this figure. Now this is a blockchain. These are three blocks, and in every block a number of transactions is stored. Now a number of these blocks are linked together to form a blockchain. Now what is a hash? No, let us first of all discuss these. So just these are some basic terms. A wallet. So basically a wallet is a digital tool used to manage with cryptocurrencies or tokens. It contains two keys, two types of different keys, public key and private key. Now, a public key is a shareable or a visible key, as its name suggests. It is also a cryptographic key, but it is a visible key. Whereas a private key is a secret key that only the user or that only the owner knows, and it allows the user to access and manage their cryptocurrency holdings. Basically, the user can manage their wallet by entering the private key. Public key is visible to everyone, but private key is just visible to its owner. Now, what is an address? An address is a unique string of characters derived from a public key used to receive cryptocurrency transactions. Address is just like a UPI ID. Like a UPI ID is in Web 2, addresses are in Web 3. Addresses can be used to transact money from we can use we can use someone's address to send them money or to request money from them. So some more basic terminologies are long. I would like you guys to see this. So basically, a hash is a string of characters generated through a cryptographic function. So we generate a hash using a cryptographic hash function, and this then a certain block has a certain hash. Like each block has a different hash, and the hash can never repeats. Actually, it cannot be repeated. The This cryptographic hash function always generates a unique hash for every block. Now, in a block, there is a hash, and also the previous hash address is also given in a block's in a block's this. So Genesis block is basically the first block of the blockchain, and every block contains its own hash as well as previous hash. Like previous hash means the hash of the previous block. Just like this second block has the hash of its own self as well as the previous block, and the third block has the hash of itself as well as the previous block. Now fork means basically a split in the blockchain resulting in two separate chains. Forking a blockchain basically means splitting a blockchain to a parent chain and a child chain. Now you guys must have heard me saying Bitcoin is based on a peer-to-peer network. A peer-to-peer or P2P network basically means the interaction is directly between participants and there are no intermediaries involved, as I said earlier. Now, what is gas? Gas is basically a fee required to execute transactions or smart contracts on the Ethereum blockchain. Whenever we transact something on Ethereum blockchain, a certain amount of fees is deducted for the system to transact those to deal with those transactions, which is called gas. The fees is called gas. Now let us understand the overview of how blockchain works with this simple diagram. Jim wants to send money to Mary. The transaction is represented online as a block. Let us say this is the transaction which Jim wants to send to Mary. Now, this money gets distributed across the network. Now, if let us take an example of Ethereum. If Jim wants to send money to Mary and he wants to transact through Ethereum, now this money is in a block A. So this block A gets distributed across whole Ethereum network. Now, this network verifies if the transaction is valid or not. using the public addresses or private addresses. These transactions are verified using through the miners or validators. Since Ethereum is using proof of stake, so we'll call them validators. Now the validators validate this transaction. Now if the transaction is successfully verified, the block is added to the chain. Now if the block is added to the chain, uh, there is a permanent record in the blockchain. So what is a blockchain? Blockchain, as I had told you in the first slide itself, blockchain is basically a distributed ledger. So now the record of this transaction has been stored in the ledger. Now Jim's record of ownership of the money moves to Mary. Now the money earlier the money was owned by Jim, but after transacting and creating a permanent record on Ethereum, the ownership of the money moves to Mary. This is basically how a blockchain works. Now let us dive into this development part of blockchain. So we will be developing in Ethereum blockchain. So we will just let's start with smart contract. So basically, smart contract is a self-executing program that automates the actions required in a agreement or contract. Basically, it is a self-executing contract that is stored on a blockchain. It can be used for automation of a wide range of transactions, from simple financial agreements to complex legal documents. Now, smart contracts are they permit trusted transactions and agreements, and they are also accessible to anonymous parties without the need for a central authority or a legal system, and they are very efficient in external enforcement mechanism. The simplest example of a smart contract is a transaction between a consumer and a business where a sale is made. So there is a consumer and a business. Now the what a smart contract does, it executes the customer's payment and the business's shipment or transfer of ownership. So it automates the this thing, the action of customer's payment as well as business's shipment. So the ownership is automatically transferred between the customer as well as the business. Now, what is Solidity? Solidity is basically a language in which we write a smart contract. So it is based on Ethereum blockchain. Now, Solidity is a high-level programming language which is specifically designed for developing smart contracts on Ethereum virtual machine, and it is an object oriented language, just like you guys must have heard about the term object oriented, just like C++ or Java. Solidity is statically typed language, which means that variables must be declared with a specific data type before they can be used. Solidity enables creation of decentralized applications as well as which and self-executing contracts, which are obviously smart contracts. So uh, and Solidity is tightly integrated with Ethereum Virtual Machine, which is the runtime environment of the smart contracts which are deployed on Ethereum blockchain. So now it is just like any other object-oriented language. It also supports inheritance and encapsulation, etc. Now, some features of Solidity are high-level abstractions. Solidity provides high-level abstractions like contracts, state variables, functions, modifiers, etc. to make it easier to develop smart contracts. And one of the major features of Solidity that distinguishes it from other languages is static typing. Static typing ensures that variables and expressions have compatible data types, which reduces the risk of runtime errors. Now, Solidity supports libraries which are reusable modules of codes which can be imported into other contracts as well. Like libraries can be imported to different contracts, and obviously Solidity also uh, supports user-defined data types, which is also a very big advantage of using Solidity. Now, let us go into development of smart contracts with Solidity. So, for development of smart contracts using Solidity, first of all, a smart contract is defined using the contract keyword, which is followed by the contract name and curly braces enclosing the contract's code. Now, let us uh, skip this part as the development part is would be too much hectic for you guys. So I will just explain how a Solidity code is written. So basically, first of all, a contract is defined just like in any other language. Um, like functions are defined in other languages. Then state variables. State variables basically are global variables uh, which have a global scope. Then different functions are defined for different works. Then modifiers are defined, which modifiers has basically special functions that can be applied to other functions that to alter their behavior without the changing of the code. Now after that, the after writing the code, the program or the smart contract is deployed to the Ethereum blockchain using a compiler like Remix or a deployment tool like Truffle or Hardhat. Now, Solidity has many applications like development of decentralized finance applications such as lending protocols or decentralized exchanges, etc., or other or NFTs, non-fungible tokens, which are unique digital assets that can be created and managed using Solidity, and decentralized voting applications, etc. Now, I would like to refer you all the official documentation, the official Solidity documentation. If you guys want to learn Solidity, it is more than enough to learn the coding part of Solidity. It has resources for learning the syntax, features, and best practices of Solidity, and as well as numerous online courses are also available, which just majorly focus on the coding part of blockchain, that is Solidity. Now, after that, you guys can also make hands-on projects to practice for the real world projects and contribute in open source projects as well. Now let us move ahead. Use cases. So there are many use cases of blockchain which are applicable to the real world as well. First of all, cryptocurrency. Secondly, smart contract, which helps in development of Web3 based applications. Third is decentralized finance, which we will be discussing later. Fourth is gaming, blockchain based gaming. Supply chain tracking, counterfeiting protection and data privacy. Decentralized governance, verifiable ownership of assets, etc. Now, one of the biggest confusions that I have had dealt with while taking sessions earlier is crypto a subset of blockchain? Yes, as I discussed earlier, you guys also must have understood this. Crypto is a subset of blockchain. Blockchain is the underlying technology that enables the creation of a cryptocurrency. These cryptographic techniques, uh, which have been used in cryptocurrencies, all are controlled using blockchain. However, cryptocurrency is a significant application of blockchain. The technology itself for broader use cases beyond digital currencies, which means cryptocurrency is a subset of blockchain, but blockchain has a broader use, which can revolutionize different fields like healthcare management, gaming, supply chain tracking, decentralized governance, finance, etc. Now, let us go inside decentralized finance. So basically, decentralized finance is an emerging financial system that utilizes decentralized technologies such as blockchain to provide financial services without the need of intermediaries like banks or financial institutions. DeFi, decentralized finance is also abbreviated as DeFi. So DeFi aims to democratize finance, making it more accessible, transparent, and user-centric. Now, there are some characteristics of decentralized finance. Uh, First of all is decentralization. DeFi platforms operate on decentralized networks or blockchains, eliminating the reliance of centralized authorities for financial services. And it is transparent. DeFi transactions are transparent and publicly recorded on the blockchain. Accountability, accessibility, as well as composability. Now, DeFi platforms are accessible to anyone with an internet connection, regardless of their location or financial background. These protocols can be interconnected and combined to create innovative financial products and services. Now, there are a wide range of financial services which DeFi offers. For example, decentralized exchanges, which means lending or borrowing in a peer-to-peer trading network. Uh, Lending or borrowing protocols, decentralized exchanges. Basically, decentralized exchange is a very wide field in itself. Decentralized exchange means a peer-to-peer trading of cryptocurrencies without any need of intermediaries. Basically, trading of cryptocurrencies means the trading in between different cryptocurrencies. Now, lending protocols, which are used to borrow or lend cryptocurrencies, which makes the user earn interest on their holdings. Stable coins are basically cryptocurrencies which are pegged to a fiat currency or a basket of assets, offering price stability for transactions and payments. And there are many. Uh, Let us cover yield farming also. So, yield farming means staking or lending cryptocurrencies to DeFi protocols to earn rewards in form of tokens or interest. Now, DeFi is poised for increasing adoption and integration with traditional finance, while regulatory frameworks are evolving to balance innovation with consumer protection. So, basically, DeFi is increasing its adoption with the traditional finance, which gives us a balance between innovation and consumer protection. Now, as you guys have must heard terms like NFTs and DAOs from my mouth. So now we will discuss about them. NFTs are basically it means non-fungible tokens, which means they are unique digital assets that represent ownership of a specific artwork or anything which is like, let's say, a piece of land or any collection which you may own, which you have to uh, upload on the blockchain, and then it gives you money. So basically, anything digital or anything which has anything related to art, you can upload it and earn money. DAOs are basically organizations. DAOs means decentralized autonomous organization. These are basically organizations that operate on decentralized governance, meanings they allow participants to collectively make decisions and manage resources without relying on a central authority. An organization means a group of people where a central authority is the head of the organization. But a DAO means a group of people where the authority lies among each one, which means the authority is in equal terms among all of the people participating in the organization. And stable coins we have already discussed. Now, career opportunities in blockchain. Okay, so reasons that make blockchain technology the best growing career choice for tech enthusiasts. So, I guess many of you guys attending this session have may have heard the term blockchain or other terms involved in this session for the first time in your life. So, which also signifies that this blockchain technology has very less competition as it is still evolving, as well as it is a revolutionary technology that has endless use cases. Now, since the competition is less, automatically the salary which is given is high. Now, different career opportunities that one can think about in blockchain is as a blockchain developer, like developing the apps and projects. Then there is blockchain solution architect. There is blockchain project manager, managing projects related to blockchain. Then blockchain legal consultant, managing the legal terms of blockchain. And then blockchain quality engineer. Now these were the various future aspects regarding blockchain technology. Now let us see some challenges and future trends of blockchain technology and the challenges that it have to deal with. Now the figure that you can see in this slide is a blockchain trilemma. So basically it means there is right now not many blockchain technologies that can deal with all these three major issues. The first one is security, the second one is decentralization, and the third one is scalability. Now, Ethereum or Bitcoin are secure as well as decentralized, but they are not as much as scalable as Stellar or Ripple. Now, Hyperledger and Ripple are secure as well as scalable, but they are not as decentralized as Ethereum. Nano as well as IOTA are decentralized as well as scalable, but they are not as secure as Bitcoin or Hyperledger. Now, some of the challenges are scalability. Scalability basically means handling a large number of transactions efficiently, which means scalable means the more scalable a blockchain is, the larger its user base would be. Now, interoperability means communication between two different blockchains. Security means you all know protection against any attack or ensuring data integrity as well. Decentralization, removing the centralized authorities, and integration. Integration basically means blockchain integration with existing systems and industries, just like integration of decentralized finance with these traditional financing methods. So basically, blockchain trilemma means we need to find a blockchain which is which has all these three features: security, decentralization, as well as scalability. Now, this was all from my side. Thank you guys for your precious time and wish you guys best of luck for your future. Thank you.